Phones away. Okay, today we're going to be talking about rocks and how they form. All right? So let's see what you got. I need a student volunteer. Ma'am,
Me.
please step forward. All right, so right here we have sedimentary, igneous, and metamorphic rocks, three types of rocks. How we have an assortment of rocks, all I need you to do is sort them where you think they go. No prior, have you taken geology courses before? No. All right, just you sort them to the best of your knowledge, see what happens, okay? And then we'll come back later after this lesson and see how you've improved. Excuse me. Interesting. Now, are you using a search strategy? What are you looking for when you sort these? Or are you just kind of guessing?
I was guessing.
You want? That's fine at this point.
Oh. You got it.
Okay, good job. Okay, you can go. Yeah, good job, everybody. Give a round of applause. All right. So I'm gonna say a few of these are wrong, a few of these are right, I think. But we'll learn, and we'll hopefully by the end of class you'll be able to sort those in the right categories. All right. There are three different types of rock. The pun, the rock played that character. Three different types. Funny, guys. You can laugh. It's a fun. Thank you, sir.
Good one.
All right, hit me again. Let's just look at it. All right, there's igneous, metamorphic, and sedimentary, okay? These are three main types. Let's see. Each have their own unique characteristics. That's why you can sort into each category, okay? They have things about them that make them what they are. All rocks fall underneath these three categories. If you found a rock on the ground, you can put it in one of these categories. It'll all work out in the end. And there's a wide range of rocks, and just because something's igneous doesn't mean they're all going to look the same. I mean, there's a wide variety of igneous rocks, metamorphic, sedimentary, crazy ton of rocks. All right, let's start off first with igneous. Igneous rocks in Latin, it means fire or born from fire. And basically what this means is it started out as a liquid, a molten rock, either as lava or magma. Lava is melted rock on the surface of the earth. Magma is still inside the earth's crust, okay? And as they cool, they form crystals. And like lava's on the surface, so it's cooler. It will cool faster, so the crystals will be smaller. They have less time to form. And let's see, igneous and metamorphic rocks make up 90% of the Earth's crust. So basically, the crust is just the surface of the Earth, and a majority of it, these two types, are just igneous and metamorphic. All right, more in depth, let's look at the intrusive and extrusive types of igneous rocks. So first of all, we have intrusive, which means these rocks, when they cool from magma, since it's inside the Earth, they have a lot longer to cool because they're not on the surface. Their heat isn't really escaping as fast. So as they have a long time to cool, the crystals have a lot longer time to form. And that's like if you look at a piece of granite, you can see like actual crystals inside of them, or diorite, same thing. And now extrusive means they've cooled outside of the crust, which actually we have an example right here. Obsidian or volcanic glass. It's erupted from lava, it cools from lava, and if you look at it, you can see it's really smooth. You can't see any crystals. It's really, you feel it's really smooth, and that's because it cooled really fast. The crystals are tiny. You can't see them, and yeah, that's extrusive. Yeah, examples are like basalt and obsidian. All right, now let's move on to metamorphic rocks. This metamorphic means basically they've changed in form, and see all metamorphic rocks at one point were some other type of rock, and they've changed from that. So what they do is they are subjected to immense, like crazy pressure and heat, and they change the chemical and physical composition of the rock. And this happens like underneath the crust and just huge amounts of heat. And but the main difference, this is the main, like one of the big things about metamorphic igneous. This rock, it changed from heat, but it never actually melted. Because if it melted, then it's instantly boom, you're an igneous rock. These never melted; they were just really, 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 really hot. All right, foliation. This is a big characteristic of metamorphic rocks. So what is it? Foliation is the response to extreme pressures that come along with metamorphic rocks. And you look over here, you see all the minerals inside the rock. They're all angled in different ways. But what happens if you get pressure and you squeeze them, those minerals are going to tend to align in a certain direction, parallel or perpendicular to the pressure applied. So I can't sit here and smash a rock and have it all align, but if you bury it underneath thousands and millions and billions of tons of earth, that will happen. And actually we have a sort of this wrong, but you can see in this rock right here, the foliation patterns, how they're parallel. You can see right there. And if you look at it actually, take it back real quick. You can see like the pressure came, like where was it squeezed from? Can you tell me?
The top.
The top and the bottom, yeah, because the foliation patterns will happen perpendicular to the pressure applied. All right, and then you go back actually. Foliation is a great way to distinguish metamorphic rocks. Now we'll get to it later, but sedimentary rocks also can have layers, but the folds is what you're looking for. And since metamorphic rocks are the only type of rocks that are put underneath like this immense pressure and still like don't change rocks, that's a good way. It helps you identify if that's a metamorphic opposed to a igneous or sedimentary rock. All right, now we're at sedimentary. Now sedimentary rocks, they cover about 73% of the surface, but it only acts as like a shell to all the igneous and metamorphic rocks in the crust. Because they're just like on the surface basically, but you go deeper, igneous, metamorphic all over. So they're formed from weathered rocks coming together and being cemented together. So basically, and we'll get to this later, the other rocks, metamorphic or igneous, they're weathered away through wind, water, any other types of weathering methods, and they're eroded away, and then they're deposited wherever they end up, where the wind blows them. Like here, sandstone, the wind blows the sand and it finds its final resting place, and over time, more and more layers are pushed together, and eventually it becomes a rock. So they're made of many clasts, which can vary in shape, size, and composition. The clasts are basically the small, they can vary in size. They can be a pebble or like microscopic grain of silt or clay. And those are just, they all come together to make the final product, which is a sedimentary rock. This type of rock would be impossible without weathering erosion. If rocks never broke down and like were worn away, eroded away, you wouldn't have sedimentary rocks. But since they do, they break down over time, they end up becoming sedimentary. All right, so what actually happened? How does like all these clasts come together, and how do they actually make a rock? So this is a process called lithification. Lithification is when clasts come together through pressure, and you can see here, the spaces in between, first of all, they're open. That first example over there would not stick together. It'd all fall apart. But with enough pressure and water coming in there, and it deposits minerals in these spaces, which you see like right here, and those minerals, that's like the glue, the cement that keeps it all together. All right, now this is basically how all rocks are related. And so you can get any type of rock from any type of rock. You can get a sedimentary rock from a metamorphic igneous. It doesn't matter. So we'll just start over there with magma. There's two ways which magma can change. It can either, one way, it can just cool into an igneous rock, and then an igneous rock can melt back into lava or magma. And then you look at metamorphic rock, if it melts, your magma, and that's how it gets to igneous. And now from igneous to metamorphic, you just add that immense heat and pressure, boom, you got yourself a metamorphic rock. And you look, both these arrows represent like weathering or erosion, and that creates sediment. And the sediment, as we talked about earlier, is deposited to make sedimentary rocks. It's all connected. You can get any rock out of any type of rock. All right, now come back up here. Let's see if you can sort these in the correct order. You guys can both come. How about we both come and see what you got? Let's put geology knowledge to the test.
No, that one's right. That's rock. Rhyolite rock, petrified wood is a sedimentary rock. Sandstone, siltstone are both sedimentary rocks. This is igneous, also sandstone, sedimentary.
Wow, I'm a great teacher because you guys just got 100% on the rock quiz. Any questions? Why is that what it is? Why are some rocks not what they are labeled? Why is it? Do you have any
Why
questions?
is your rhyolite a quartzite?
Yeah, it is.
Why?
It is because but we were going off the label, and obviously, but why? So tell me, why is this rock igneous?
Do they have the crystal?
It does, yeah, it does have crystals, but like, how did that rock form? Can you tell me that? Remember when I talked about like extrusive and intrusive? Which one cools faster? Something on top of the crust or beneath the crust?
Which one cools?
Cools faster.
On the top.
Yeah. So that's volcanic glass. It cooled very, very quickly, and that's why you can't. If you look closely, you can't actually see the crystals. It's all smooth.
So is it extrusive?
Yes, that is an extrusive rock. Any other questions? Good job. We're good?
We done?